Assalamualaikum and a very good morning. My name is Fitriah Isa and I'm going to present the title of my paper, Hydrological Performance of Green Roof System in Tropical Regions. So basically, this is the presentation outline. So we're going to start with the introduction, and the second point is we're going to discuss on the benefits of green roofs. The third one is how the performance of the hydrological performance of green roof system. And then the fourth one is how to determine the hydrological performance of green roof, and then we are going to conclude everything. All right. For the introduction, so the threat of climate change is a key driver for sustainable development in Malaysia, and one of the ways is to have a green roof system, as it offers a sustainable solution to improve resilience to the negative impacts of climate change. So it is believed that by developing green roof system or GRS in dense urban environments, it will help reducing pressure in storm water systems and improving air quality. GRS typically comprises several components, including vegetation and substrate, a filter layer and drainage material, insulation, a root barrier, and waterproofing membranes. So it is submitted that the optimal selection of each component of a GRS is important to the hydrological performance of the GRS. So there are two distinctive types of GRS. One is extensive and the second one is called intensive. While the semi-intensive green roof is not popular and it lies between extensive and intensive properties. So for intensive green roof, it has a very thin layer of low growing vegetation, while for the intensive green roof system, it has a heavier construction with a deep growing medium. So this paper explores the hydrological performance of GRS, focusing on in tropical climate countries and specifically Malaysia. So what are the benefits of green roof? The benefits of green roof are several, including enhancement of heat transfer through roof and the provision of a cooling effect in warm climates. It is believed to reduce the impact of the urban heat island in hot climates, improving air quality and ambient temperatures in urban areas, reducing stormwater runoff and greenhouse gas emission, and able to reduce noise, and it is applied for aesthetic beauty as well. So in a research by Sims et al., it suggests that the performance varies with climatic regions, where, for example, drier climates such as the semi-arid and continental regions have greater percent cumulative stormwater retention than humid region. And according to Fitriah Isa, it is very difficult to assess hydrological performance due to a lack of climatic data or the prohibitive cost of field experiments. So we're going to find what will affect the hydrological performance of green roof systems. As mentioned before, GRS performance varies with climatic regions, and it actually depends on rainfall events and the antecedent moisture conditions, or we would like to short form it as AMC, prior to the event in any climate. And in Malaysia, as the humid continental regions, we have higher levels of stormwater retention. So these are the key factors in the performance of GRS. Green roof actually reduces rainfall runoff rates through interception by the plant cover, by detention and retention for evapotranspiration or ET by the substrate, and the additional storage capacity in the drainage reservoir. This suggests that the hydrological performance of a GRS is a complex mix of evaporation and transpiration, and it is actually dependent on the antecedent moisture conditions, rainfall intensity, and the hydraulic properties of the soil. So it is necessary to balance factors such as water holding capacity, weight, and hydraulic conductivity while providing sufficient moisture for the plant system. So basically, this is the model of conceptual green roof, where it can be shown from this figure that the green roof system, water storage compartment, and how does the moisture fluxes entering and exiting the system. So hydrological performance of green roof system is a complex mix of evaporation and transpiration potential, which is dependent on the AMC, rainfall intensity, and the hydraulic properties of the soil. And it can be concluded that regional climatic condition, microclimatic factors, and the idiosyncratic site characteristics plays important role in determining the performance of GRS system. So, how can we find the hydrological performance of green roof? We need to study on several data on the subject of hydrological performance itself, as the research is not well explored in Malaysia. Little attention has been made in green roof system research in Malaysia. So we need to combine all the literature data from past research and findings from other countries as well, in order to add to the bank of knowledge on the design of these systems in Malaysia. So, based on the past research and findings, according to Locatelli et al., he points out that the hydrological performance response of green roof is highly affected by ET rates, and the long-term performance of the system is influenced by single event runoff and evapotranspiration rates. And it is supported by Carson et al., and he added that pilot studies on Juris can provide misleading results when developed as a full-scale green roof. And Fassmann-Berg et al. In 2014 stated that runoff depth is strongly influenced by rainfall depth. And in Hong Kong, there is a study by Young et al. He and his friends mentioned climatic condition determines the moisture balance in green roof in the tropical climate of Hong Kong. And he added that wind speed and atmospheric turbulence influencing ET rate as well. Viola et al. Added that soil depth and climate affected the retention capacity of the green roof, and the performance of a green roof system increases when rainfall and potential ET exhibit the same seasonality in the hydrological year. According to Lim and Wu, the hydrological retention rule of a GRS in tropical areas can be increased by increasing the spatial coverage within a catchment or by using deeper growing media. So this research has been made in Singapore, a country which has a quite similar tropical condition like us, Malaysia. For Wong and Jim, they mentioned that rainfall depth also affected the retention capacity, including the ADWP or the antecedent dry weather period, wind speed, and solar radiation. And Stovin et al. In 2015, she made a research in United Kingdom, added that the ET is dependent on several interdependent factors, and the substrate moisture content rather than times determine the difference between actual and potential ET rates. So based on this graph, we can see that the performance of runoff retention, runoff onset delay, and peak flow reduction of the green roof, which is highlighted in the green graph, is actually better compared to a conventional concrete roof system, which is represented by the blue legend. And we can conclude also that the Juris hydrological performance, these are the key factors that affect the hydrological performance of a green roof system. If we want to develop a good research basically on the performance on green roof, we need to have all this data together, and based on this data, a good and reliable hydrological performance of green roof system in Malaysia can be explored. So one of the key factor is antecedent moisture condition. We need to know the rainfall intensity as well. We need to get the data of wind speed and solar radiation at that site location. And of course, we need to find the correct or the suitable substrate type and also the vegetation. Of course, the thickness also will play an important role to the performance. And that's not all. We need to know the hydraulic properties of the soil. So we need to do the soil test as well. So if we do the laboratory studies, we need to have a certain mechanism in order to control the climatic variables. And together, when we combine all the key factors, a good, reliable research based on the green roof system of Malaysia can be successfully developed. So as a conclusion, the optimal design of Juris is complex depending on integral factors. So we can say that in tropical regions in Malaysia, the key factors affecting evapotranspiration and retention are 1. Rainfall intensity. 2nd, the antecedent dry weather period or ADWP. The 3rd one is wind speed. The 4th one is solar radiation. The 4th one is humidity. And of course, the soil, the type of soil, the depth of soil, and the planting also influencing storage and retention. It is difficult to define specific parameters for the efficient hydrological performance of a green roof unless there is detailed climatic and meteorological data available for the specific site being assessed. Thank you for your time.